Hello everyone, welcome back to another video. It's been quite some time since I have made a video on IB chemistry, and mainly that's because of university and just how busy I have been with everything else. But now I'm back and I'm going to answer some questions regarding HNMR and a bunch of other topics, and I will make a few more videos in the upcoming days which will hopefully help you with your IB exams, which are soon to come, right? So let's take a look at this question. So this is question number 38 from paper 1HL. A subscriber sent me this question to answer, and it's to do with the HNMR spectrum. So the question asks, what is the ratio of areas under each signal in the HNMR spectrum of 2-methylbutane? So okay, first thing that I want to do is I want to draw out 2-methylbutane. How does 2-methylbutane look like? So it looks something like this. You have 4 carbons because it's a butane, and it says 2-methyl. So it's going to have a methyl group on the second carbon in butane, and the rest is going to look something like this, right? So this is our 2-methylbutane. Now this 2-methylbutane, how many hydrogen environments does it have? Now what is essentially the HNMR spectrum? The HNMR spectrum tells us how many different hydrogen environments are present in a molecule. And how do you determine the number of hydrogen environments? Well, you look at each carbon. You look at the hydrogens on each carbon. So if I look at the hydrogens on carbon number 1, okay, I'm going to look at the number of hydrogens. I'm going to look at the hydrogens on this carbon. Well, all these 3 hydrogens are in the same environment, right? So I'm going to say environment number A. They're all in the same environment because they're attached to the same carbon. So they're all in the same environment, right? But if I look at this hydrogen over here, which is attached to carbon, this carbon over here, carbon number 2, we'll number the carbons. Would this hydrogen be in the same environment as these 3? Well, no, it would not, because the carbon that this hydrogen is attached to 2 other carbons, right? This carbon number 2 is attached to carbon number 3 and carbon number 4. Just example, I'm just giving them random numbers, yeah? So there we go. So this hydrogen over here is going to be in environment number B, because it is in a totally different environment than these 3 hydrogens over here, because these 3 hydrogens are attached to 1 carbon, and this 1 carbon is only attached to 1 other carbon. So again, it's not the same, right? This hydrogen over here is completely different, is in a different environment. You can think of environments as neighborhoods, right? So imagine you live in one neighborhood and your friend lives in another neighborhood, right? If you and your friend live close to each other, you live in the same neighborhood, then you can consider yourself to be neighbors. However, if you look at hydrogen number B, if you look at environment number B and you look at environment number A, they're totally different, right? They are not similar to each other. So, okay, fine. We've determined we have 2 environments. Let's look at the number of hydrogen. Let's look at these hydrogens over here. Okay, let's look at hydrogens on carbon number 4. Okay, let's look at these hydrogens. What about these hydrogens? Are these hydrogens in the same environment as any other, or are they in a new environment? Well, you may look at this and say that they are in a different environment, but that is actually not true. They are in the same environment as the hydrogens in A. They are in the same exact environment. And why is that? Because if you look at these 2, right, you look at these 2 parts of this molecule, you look at these 2 parts, right, you look at these 2 parts, and you soon realize that they are essentially the same. There are 2 methyl groups attached to the same carbon, right? Both these carbons, carbon number 4 and carbon number 1, are both attached to carbon number 2, and both carbon number 1 and carbon number 4 have 3 hydrogens on them. That means that they are in the same environment, right? Everything about them is the same. And that's why these 6 hydrogens, essentially, these 6 hydrogens, which is over here, hydrogen, we can say 1 over here, number 1, 2, 3, 4, 5, and 6. All these hydrogens are in the same environment, which is environment number A. So we have environment number A, which has 6 hydrogens so far. We have environment number B, which has 1 hydrogen. Now let's take a look at the other hydrogens. We have two hydrogens on carbon number 3, right? We have two hydrogens over here. Now these two hydrogens are in a completely different environment. They are not the same at all to anything else in this molecule, right? They're two hydrogens and they're attached to one carbon, and this one carbon is attached to two other carbons, and it's totally different. You can see how these two hydrogens are nothing like, or they're not in the same environment as the other ones. So we have new environment, environment number C. We have environment number C. So environment number C has two hydrogens. Then let's take a look at the number of hydrogens on carbon number 5. We have carbon number 5 over here. We have 1, 2, 3. We have 3 hydrogens, and are these in the same environment as any other hydrogen? So we have environment number A, right? You can think of it as neighborhood A. In neighborhood A, we have 6 hydrogens. Do these 3 hydrogens on carbon number 5, are they the same as these 6 hydrogens in neighborhood A? Are they? Let's take a look. So the 6 hydrogens in environment A, the 6 hydrogens in environment A are attached to a carbon, and then that carbon is attached to another carbon, right? And that's what puts them in the same environment. However, if you look at carbon number 5, or if you look at the hydrogens on carbon number 5, this, and this, they are in a totally different environment, right? They're attached to a carbon, and that carbon is attached to another carbon which has 2 other hydrogens attached to it. So it's not in the same neighborhood. If you look at the location, if you look at the neighborhood, it's not the same at all, right? So these are in a totally different environment by themselves. So you can consider this as environment number D. We have a new environment, and D has 3 hydrogens in it. Now, if you look at basically the options that are given to us, right? What is the ratio of areas under each signal in the HNMR spectrum? What does the ratio of areas tell us? The ratio of areas basically tells us how many hydrogens are present in each environment. So if you have seen an HNMR spectrum, right? If you just Google up HNMR spectrum, you would see something like this, right? You have like a bunch of lines, and each different group or each different line represents a different hydrogen environment. So this could be something like A, B, C, D, different hydrogen environments. And the area, the ratio of areas under the signal, in each of these signals, tells us how many hydrogens are present in each environment. So in our case, in environment A, we had 6 hydrogens. In environment B, we had 1 hydrogen. Environment C, we had 2. Environment D, we had 3. I'm sorry, it's getting a bit cramped. But hopefully you understand what I'm getting to. So what is the ratio going to be? We have 6, 1, 2, 3. And out of these options, which one makes sense? Well, that is option number A. So the correct option is option number A. And hopefully you have understood what is going on. And I completely agree if you have completely understand if you have not understood this, because it is a complicated topic to both understand and explain. But if you have any other questions, please send me a message on my Instagram, and I will be more than happy to help you out and help you understand this. Please do not hesitate to ask questions. They are very important. And thank you so much for watching this video. If you have any other questions, again, let me know. I'm always open. I'm always open to answering questions. And that is it for this video. Take care of yourselves, and I will see you in another video with another question. Bye-bye.